All right, welcome. Today we're going to crack open one of the most useful tools in your entire algebra toolkit, the power rule. You know, if you've ever just stared at an exponent that's raised to another exponent and thought, what do I even do with that? Well, you've come to the right place.
So, look, you've probably got the hang of something like x squared times x cubed, right? You just add the exponents. Easy. But then you see this thing with the parentheses, a power raised to another power. It's a totally different beast, a new kind of puzzle. And guess what? We're going to solve it right now.
Okay, here's the game plan for today. We'll start with what a power on a power even is, get the core rule down, then run through a bunch of examples to really lock it in. After that, we'll talk about the common traps people fall into, and finally, we'll see why this whole thing actually matters in the real world.
All right, let's dive right in. Section 1, the core rule. We're not just going to learn what it is, we're going to understand the why behind it.
And here it is. It's actually surprisingly simple. The power rule is this. When a power is raised to another power, you just multiply the exponents. That's it. See those parentheses? That's your big signal. That's your cue to think multiply, multiply, multiply. But okay, why does that work? It's not just magic, right? Well, let's break it down. Think about what x squared cubed actually means. It just means you have x squared times itself 3 times. So x squared times x squared times x squared. And we already know how to handle that. That's the product rule. We just add the exponents, 2 plus 2 plus 2, which gets us to 6. So you see, multiplying the 2 and the 3 is just a super fast shortcut to get to the same answer. It's all connected.
Okay, knowing the rule is one thing, but using it is where the real learning happens. Let's get into some examples and put this rule to the test.
All right, first up, a nice clean one. We've got y to the 5th power, and that whole thing is being raised to the 4th power. So what do? We see the parentheses, we see a power on a power, and we immediately think multiply. So we do 5 times 4, which is 20. And bam, there's our answer, y to the 20th power. See? Not so bad. Okay, but what if there's more going on inside those parentheses? What about numbers, coefficients? This is super important, so listen up. That power on the outside, it's got to go to everything inside. Every single piece. Let's see exactly how that works. We've got 2x cubed fourth. So that 4 on the outside has 2 jobs to do. First, it goes to the number. What's 2 to the 4th power? 2 times 2 is 4, times 2 is 8, times 2 is 16. Got it. Now, for the variable part, we have x cubed raised to the 4th. That's our power rule. 3 times 4 is 12. So we get x to the 12th. Just stick them back together, and you've got your answer, 16x12. Ready to put it all together? Let's tackle this one. Negative 3a squared b to the 5th squared. Okay, don't let it intimidate you. It's the same idea. That little 2 on the outside has to visit everyone inside the party. First, the number. What's negative 3 squared? Remember, a negative times a negative is a positive, so that's 9. Next, the a. We have a squared squared. Power rule says we multiply. So 2 times 2 is 4. That's a to the 4th. Finally, the b. b to the 5th squared. 5 times 2 is 10. That's b to the 10th. Put it all together. 9/8 the 4th, b to the 10th. Done. So you're feeling pretty good about the rule now, right? Awesome. But before we get too confident, let's talk about the common traps. These are the simple mistakes that catch everybody at first. Let's make sure they don't catch you. Okay, mistake number 1, and this is the big one. Adding when you should be multiplying. It's so easy to see x squared cubed and have your brain just shout 2 plus 3 is 5. I get it, it's a reflex. But you have to fight that reflex. Remember, the parentheses are the key. They mean groups of. You have 3 groups of x squared, which is why we multiply to get x to the 6th, not add. And here's the other classic trap, forgetting the coefficient. We get so focused on the variable, the x squared part, that we just leave the 3 behind. Poor little guy. But that exponent on the outside, in this case the 2, it applies to everything. You have to square the 3, which gives you 9. The correct answer isn't 3x to the 4th, it's 9x to the 4th. Don't leave that coefficient out in the cold. So you might be thinking, okay, I get the rule, but when am I ever going to use this? Fair question. Let's talk about why this rule actually matters and how it pops up in the real world. Okay, let's think about something simple. A cube. We all know the volume of a cube, right? It's just the length of its side cubed, side to the power of 3. Pay close attention to that little 3 up there. Now here's the interesting question. What happens to the volume if we decide to double the length of the side? So instead of S, the side is now 2S. Your first instinct might be to say, well, the volume probably just doubles too. But does it? Let's use our new power rule and find out for sure. So the new volume is going to be 2S cubed. Hey, look at that. That's a perfect job for the power rule. We have to give that power of 3 to both things inside. So 2 cubed, that's 2 times 2 times 2, which is 8, and S cubed is just, well, S cubed. So the new volume is 8S cubed.
Did you catch that? The original volume was S cubed. The new one is 8S cubed. That means when you double the side length, the volume doesn't just double, it gets 8 times bigger. That's wild, right? And the power rule is exactly what lets us figure that out. So now the power is in your hands, literally. We just proved that doubling the side makes the volume 8 times bigger. So my question for you is, what happens if you triple it? Take a second, use the rule we just learned, and see what you come up with. The answer is pretty amazing. Go give it a try.